Kia ora team and welcome to another online tutorial. Today we're going to be talking about phasor circles, specifically using formula to calculate displacement / extension, velocity and acceleration. A reminder that capital A is our amplitude and lowercase omega or wiggly w is our angular velocity. They've given us two sets of equations here. The equations above are to be used when we start at maximum velocity or at an equilibrium position. The equations below are to be used when we start at our amplitude or displacement maximum, which would be our highest acceleration. The reason we use different equations is because we add a different point in the reference circle. Therefore, when we do trig, we have to use sine in case of cos and vice versa. Okay, let's get stuck into the question. So an object moving in standard harmonic motion has a rotational velocity of 2.5 rads per second. Remembering that when we use rads, to make sure that your calculator is set to rads and not degrees, and vice versa. Be very careful, this does catch out a lot of people in exams. And an amplitude of 0.335 meters. Calculate the displacement, velocity and acceleration after 10 seconds. Timing began when the velocity was at a positive maximum. They've said the velocity is at a positive maximum, so we know that we're at the point of equilibrium and we're going to use our equations from above. Okay. I'm going to note down any worthwhile information, specifically our rotational velocity, which is 2.25 rads a second or radians a second. Okay. Our amplitude, capital A, which is 0.335 meters, and time, which for us is going to be 10 seconds. Okay, more specifically 10.0 seconds. So they want us to calculate the displacement, velocity and acceleration using these figures. And again, they've stated that it's at a positive maximum, so we're using our equations above. Let's get to it. So our equation for displacement is y equals positive amplitude sine omega t. When they give you these equations in the exam, they don't have brackets. These brackets are here because you need to set those up for it to work in your calculator properly. Okay. Omega t. Now if we input the information that we have our amplitude 0.335 meters, sine our 2.25 radians times our time 10, okay, and that gives us negative 0.16320, which we will round to negative 0.163 meters. Okay, and that's our displacement out of the way. Onto velocity. Remembering we're using our equations from above. V equals A omega cosine omega t. Okay. If we input our numbers, 0.335 times 2.25 cosine 2.25 times 10, okay, which will give us a calculation of negative 0.65825, okay, which we're going to round to negative 0.658. Okay, remember we have velocity, meters per second. A reminder that the negative showing us the direction of the velocity. Let's move on to acceleration. Our equation for acceleration is a little bit more complicated, seeing as we start off with a negative amplitude times omega squared, or our rotational velocity squared, sine omega t. Okay. So if we put that in, or we insert the information that we have negative 0.335 times 2.25 squared sine 2.25 times 10. Okay, now if we plug and chug and calculate, we should get 0.826217. Okay, which we round to 0.826 meters per second squared. Okay, giving us our acceleration. Now, pretty simple, team, just working through using the equations given. A reminder though, that there's two particular sets of equations here. One from when working from Vmax, or at our equilibrium position. The other one from working at our Y or A max, which is we're at max amplitude, extension, / swing, whatever you want to call it. Okay? Remembering that we use these different ones depending on that, because we have a different reference frame, meaning the triangles in trigonometry we use the calculated if we drew out those triangles will be different. Okay? Hopefully this helps you get out there and get into some physics, team. Good luck.